protractors to connect your angle. There we go. So make sure that you've labeled everything. So if you were absent yesterday, you'll need to plot these 3 points. And what we're actually going to do is classify this triangle based on its sides. Now, when it comes to classifying triangles, we're not going to classify them. That's awful, isn't it? Okay. Good. I'm going to fall on this. I hope this fan is high-powered enough to keep us cool. This is a disaster. Okay, we're just going to start fresh. All right, so when we classify triangles in the coordinate plane, you cannot do it based on angles. The only angle that you know for sure is a 90-degree angle. That's it. So the way we're going to classify is based on sides. So we graphed first. Now we're going to calculate the side measurements using either Pythagorean theorem or counting. Okay? So pick any side you want. What side do you want to start with?
The left side.
Okay, what's the name of that side?
It's definitely not JS.
Okay. All right, so this is our left side. So you can start with any of the sides that you want to. It doesn't make a difference what order you do it in, as long as you are finding the measurements of all 3 sides. Okay? So that is our first piece. So the best way to keep your work organized is to make little boxes. I'm going to make a box here. And I'm going to title that just XJ. It's going to be easiest because we're actually going to have to do Pythagorean theorem potentially up to 3 times. Now, if things are horizontal or vertical, you can count up and down and left to right, but you can't count diagonally, which is why we use Pythagorean theorem. So exactly what we did yesterday using Pythagorean theorem, we're going to do that on this little section. So how do I build that right triangle again? How do I build the triangle of XJ? Our goal is to make a right triangle off that shape. So what I'm going to do is I'm going to take
J and Q.
So I'm going to go up and over to X. Like I'm just counting, kind of like slope, but you're just moving and drawing your triangle up and over. Basically, if you do this correctly, you'll have a rectangle at the end. Like you'll have drawn all the triangles to make it look like a rectangle or square. So now you've created that right triangle. Now you just count the sides. Now it's not like slope. Remember, if we count down, we're not going to put a negative sign because our slope is different than a side of a triangle. Sides can't be negative. Like you can't be negative 5 feet tall. Okay? So now we're going to count. So how many boxes is the vertical? Yeah, 1, 2, 3, 4, 5. So I'm not going to put change in Y or anything. That length is just 5. Now, I do not count this box. That box is off limits. It doesn't do anything. Sometimes we're tempted to count it. Okay? Then we've got the top. So how many is the top? 3. So 1, 2, 3. So when you do Pythagorean theorem, our A and our B value are 5 and 3. You can do them in any order that you want to. You could do 3 squared plus 5 squared or 5 squared plus 3 squared. So I'm just going to do 5 squared plus 3 squared. Remember, it's A squared plus B squared equals C squared, where C is that diagonal length that we're trying to calculate. So I'm going to put 5 squared plus 3 squared equals C squared. We're trying to calculate the diagonal piece. So in your calculators, our variable is by itself, so we can do 5 squared plus 3 squared. So go ahead and do that part.
34.
Okay.
34.
All right, so 25 plus 9 is 34. So we get 34 equals C squared. Okay. What is it called to undo that square? What is that called?
Square root.
Square root. So when I square root 34, do we get decimal or a whole number?
Probably decimal.
Are you sure?
Yes.
Okay, what is the decimal?
5.3095.895.
Okay, so we're gonna stop and just put it under the square root to make our lives easier. Because when we're comparing, we don't wanna really use decimals because the square root of 35 can look very similar to the square root of 34 if rounded. So we just wanna make sure that we keep underneath the square root exact so we can match up our measurements. All right, now we do it again. So what side do you wanna work with now?
X cubed.
Okay, x cubed. So we're going to do the exact same thing again. This whole thing is basically just the Pythagorean theorem for counting. So I'm going to pick x cubed. Remember, you can do this in any order that you want to.
Do we not draw a box?
Yeah, we are.
I do the bottom one then.
Hmm?
They want to do the bottom one. And get it to you.
We're just going to count it because it's horizontal and you can count left to right and up and down. Okay, so we are going to draw our box. I'm going to title this little section X cubed, because as we start to do a lot more math, it's important to kind of know where our stuff is. Okay. What we're doing is a coordinate proof. So we want to make sure that we're labeling and showing a lot of work. So I'm going to draw my triangle again, starting at Q, going up and over to X. This is a 90 degree. Remember, we don't count this box when we're counting our sides. We don't want to count that little box. So what are the sides of that triangle?
Same thing as the left side.
Okay, same thing. We should get 5 up. Can I have a side length that's -3? No, because it's not sloped. These are triangle sides, so we're not going to use negatives. Because that triangle, I can't build a triangle with -3 feet of wood.
You have -3, I guess, and very sea level.
Hmm?
You got like negative because very sea level.
Yeah, it's referred to as below sea level though. So the term below would kind of take care of the negative sign. All right, so we got 5 and 3. So again, I can rewrite a squared plus b squared equals c squared, or I can just write 5 squared plus 3 squared equals c squared. Do I have to do that math again?
No.
No, what's the answer going to be?
34.
The square root of 34. So all you actually have to do is the setup, so I know where you're getting your numbers. If you're getting the same numbers for your sides, just set the problem up and then just write the answer down. Obviously, those numbers are identical, so there's no need to do all the math again. Math is not going to change. Right? 5 squared plus 3 squared is still going to be 34, and when you square root it, you're still going to get the same decimal. Okay?
Kind of a hassle for one answer.
Hmm?
Kind of a hassle for one answer.
Yeah. It won't take near as long when you're doing it on your own. All right, how do we find the length of j cubed?
Count it.
Okay. Anytime a side is left or right or up and down, horizontal or vertical, you can count that. So you don't have to do Pythagorean theorem 3 times, right? You can just count this one. So you can't build a right triangle off of that. So from here, that length is j cubed. And you just count your boxes. 1, 2, 3, 4, 5, 6. So I know that JQ's length is 6, and the way that we got it was we counted. That's it. Once you look at the sides, once you calculate all your side measurements, then you analyze the numbers that you got. So we got square root of 34, a square root of 34, and 6. What kind of triangle is XJQ? Acute? Well, we don't know anything about the angles, so it can't be acute. It looks acute. You're probably right. But if we don't know the angle measurements, we can't assume the angles. We're classifying. Are we classifying by sides or angles?
Sides.
Sides. So our list for sides, we had equilateral, isosceles, or scalene. Isosceles. Equilateral, all of them would have to be the same. Isosceles is 2. Scalene is none are the same. So there are 2 that are identical. So right here, I'm going to say that segment XJ is congruent to segment XQ, but not congruent to segment JQ. That little 3 dot, that stands for the word therefore. Okay, so I'm going to write that up here. We're going to learn a new math symbol if you haven't seen this one yet. The 3 dots stands for the word therefore. I was misspelled therefore. So XJ is congruent to XQ, but not congruent to JQ, which means we've got 2 congruent side lengths. Therefore, triangle XJQ, or however you want to name it, is isosceles.
Oh.
I know, it's awful. That one little sentence. That's all you need to do. So as you do these, you'll get a lot faster at them. Clearly, this problem took us like 10 or 15 minutes to do, but when you're doing them by yourself, it's not going to take that long because you don't have to explain it. So all you're doing is you're saying which sides are equal or congruent in this case, and which side is not, then it's isosceles. So let's try the next one. So you should have already plotted it. If you haven't connected it, go ahead and connect the triangle. Okay. I'm connected if you haven't already. I'm gonna. You good, Kevin? You good? Okay. That part, or do you need more? Okay. All right, so I drew it, so I'm going to connect it. So let's all pick a side. What side do we want to start on?
AB.
Okay, you can start at AB. So highlight AB. Whatever color you want, doesn't matter. You want to be as organized as possible because there's lots of math going on. I'm going to title it AB. So I want you to draw the triangle off of it and calculate the length of AB. If you're doing Pythagorean theorem and you get a decimal, leave it under the square root. So to do this one, we should have drawn side down over. Remember, this is 90 degree. We don't count this weird little box. So what are the 2 side lengths for AB? Okay, 3 and 2. So I count down 2. So I'm just going to put 2. Remember, we don't think negatives when it comes to sides. We have to stop at B. So 1, 2, 3. So when you did Pythagorean theorem, what was your end result? What did you get for the value of AB? Square root of 13.
Miss O.
Yes, ma'am.
So is the 2 negative?
No, because it's a side of a triangle. We're not counting slope. So it's a little bit different because it's a triangle.
So it'll be positive.
It's always positive, right? Because think of it like building a house. Like you can't buy negative 2 feet of wood to build your house. Yeah. So I know it's hard to like not think like slope, but it's a triangle, not slope. So it's a little bit different. But if it was slope, yes, it would be negative. Okay.
Thank you.
You're welcome. So 2 squared plus 3 squared is 13. Then we square root. So we get the square root of 13. Okay. What's the next side you want? Okay, B and C. Those are the easiest. I don't blame you. I would start at BC too. So BC is here. Got to do anything special with BC?
No.
No. How long is BC? 4. How did you get that? Yeah, we counted. Remember, if it goes left to right, you can just count it. Yeah, those are the easiest ones. Left, right, up, and down, you can count. All right, take this last second to calculate the length of AC. All right, so we should have at least gotten 7 squared plus 2 squared. We're just counting. Remember, no negatives because we're working with triangle side lengths, not slope. So 7 squared plus 2 squared is 53. How do we get the C alone? Square root. Are we going to leave it as the square root of 53 or are we going to write it as decimal? We're going to leave it as the square root of 53 because we get a decimal. Franklin, I didn't get 14. I got 13 right here. Is that where you're asking your question? Sorry, I was trying to read your comment. Oh, no, you're okay. All right, so let's look at our statement. So our statement up here, we said we had some congruent stuff, but we don't have anything congruent here. So who wrote the statement? How do we write it? Gabe, you wrote a statement. Read it to me.
AC is not congruent to DC and not congruent to AC. Therefore, ABC is not scalar.
Good job. Therefore, triangle ABC is scaling. So it looks like a very confusing statement. You know, there's hardly any words. The only words in that statement is scaling. But mathematically, you know what all those pieces mean. By saying that all of the sides are not equal, that means that it has to be scaling. It's just like that IXL we did the other day, where it gave you 3 sides and you had to pick, is it isosceles, equilateral, or scaling? Same thing. And the 3 dots means therefore. You can write the word out if you want to, but that's a lot faster. Good job. Okay, on page 14. We're going to do the right triangle example in just a second. Now, the right triangle problem is different because right triangles involve slope. So that bottom example, we're not going to start yet because it's different from what we've done. Okay? So on page 14, we're going to do 1 and 2. So we're going to do another practice real quick about classifying it as isosceles, scaling, or equilateral. Okay? So just do 1 and 2 on page 14. We will come back to slope and doing right triangles in just a second. All right. So on this one, what did you find for the side length of AC?
53.
You got 53? So when you drew your triangle, how many up did you go? 7. And then 2, so you should have done your 7 squared plus 2 squared equals C squared, and you are correct. You should get the square root of 53. So I just skipped some steps. I just went ahead and put 7 squared plus 2 squared, and then I went ahead and square rooted it. So square root of 53. What did you get for AB? AB is right here. You got the square root of 53 for this line?
4.
For AB is what we want. Yeah, we got 4. 1, 2, 3, 4. I'm finding them in a different order than you did. All right, how did you get that? Yes, we count.
I guess.
CB,
53.
square root of 53 again, we should get 7 and 2. So again, 7 squared plus 2 squared equals C squared. So you should also get the square root of 53. Who's got the statement? You don't have the statement? You want to build it together? All right, what 2 segments are equal?
AC and BC.
Okay, so we're going to write AC. Then Nick, what's this symbol mean? Congruent. So AC and CB are congruent. but they're not congruent to what segment?
AB.
Segment AB. What do these 3 dots mean? Therefore, what's the rest of it? Triangle what? Wrong problem.
Oh.
ABC. Okay, triangle ABC. Finish the sentence. Is.
I can't say that word.
It's okay. Isosceles. Yes, it is spelled very weird. I cannot spell and speak it at the same time. Like I cannot write it down. I always misspell it. It's okay. So that's all you did. You got isosceles. Let's do the next one. So OM. What were our triangle measurements on OM? OM or MO, depending on how you named it. 1 and 5. So when you did 1 squared plus 5 squared equals C squared, square root of 26. What about ON? What are my triangle lengths on ON? 2 and 3. So we had 2 squared plus 3 squared equals C squared. For the square root of what? 13.
13.
All right. What about NM? 3 and 2. So 3 squared plus 2 squared equals C squared to get the square root of 13. How do we write our statement?
M and congruent of O N, and not congruent of O M. Therefore, triangle M and O is isosceles.
Isosceles. It's okay. It's a super weird word. It's got Greek origin, so it's basically a Greek word.
I don't
So
have Greek.
that's okay. There you go. So now isosceles. All right, how do we do on those 2? From what I noticed.
Hard on instead of writing.
Okay, that's fine. So what I noticed walking around, we did pretty good drawing the shape. This statement is a little hard, but just remember, you're basically saying if things are congruent or not congruent, one or the other. That's it. And then you're doing very good with the therefore symbol, with the triangle being isosceles. So good job with all the math. It's very repetitive. It's basically just a bunch of Pythagorean theorem. Okay? So we're going to go back, and Cody, you can continue to write. We're going to go back to page 13, and we're going to do the right triangle problem in just a second once everybody gets written down these 2 examples. All right, so to do a right triangle, what makes a triangle a right triangle? A 90-degree angle. So when it comes to calculating angles in the coordinate plane, the only angle that we know for sure is 90 degrees because perpendicular slopes make 90-degree angles. So for something to be a right triangle, we have to look for 90-degree angles, which mean perpendicular slopes. So in order for 2 lengths of a triangle to be perpendicular, their slopes have to be opposite reciprocals. So we spent a lot of time in the last chapter doing perpendicular parallel slopes. We're using that again. So Cheyenne, in this problem, we are going to be calculating slopes, so we will have negatives, okay? So we're not going to be doing triangles anymore. We're going to be calculating slopes, okay? Same idea, but now negatives can be a thing because we're moving in a positive direction or a negative direction. So we're going to pick any side we want to. So what side do you want to start with?
AP.
AP sounds great. So AP is our first segment. So what we're going to do is we are calculating slopes now. We are not doing Pythagorean theorem. We're calculating slopes. So remember, slopes are change in y over change in x. Change in y over change in x. you need to be going in the y direction. You need to be going in the y direction first. So you can start at A and go down, or P and go up. It's up to you. So where do you want to start? What letter? A. So how many units in the y direction do we go down in A? 2. Positive or negative? Negative 2. So my change in y is negative 2. What is my x direction? My x direction is 1. I'm going to leave it as a fraction because it's going to be a whole lot easier to compare slopes if they're a fraction. So we're going to leave that as negative 2 over 1. There's nothing, bless you, to simplify. The fraction doesn't reduce. We could write it as negative 2, but remember, it's easier to see the reciprocals if you have a fraction. All right, now we pick the next one. What's the next side you want to work with? What? A and x. So A, we're going over to x. Remember, our goal is slope counting. And at the end result, we're trying to find opposite reciprocals. So change in y over change in x. So how many in the y direction do we go? Okay, we go 1, up 1. So is that a positive or negative? Good, positive 1. Notice how we're kind of filling it out as we go. Write your fraction first so it's easier to count and fill in. Okay, what about in the x direction? 7. So 1, 2, 3, 4, 5, 6, 7. Positive or negative? Positive. So the slope of AX is 1 over 7. This is actually a lot faster than Pythagorean theorem because you don't have to square anything or add anything or square root. You're just counting. So our last length is XP or PX, however you want to name it. Same thing. So this is our last one. Remember, our goal is to count the slope here. We call it XP. Change in y over change in x. We want to go in the y direction first, so we always put our fraction the right way. So I'm going to start at x. I think it's easier to count outside of the triangle than versus trying to count up inside. It can get a little messy, so I would just stick to the outside. So that would mean we have to start at x first. How many units in the y? Okay, 1, 2, 3. What's my sign? Negative 3. X direction? Negative 6. 1, 2, 3, 4, 5, 6. Does that fraction simplify or reduce? Because right now, none of them look the same. Okay, what is that as a reduced fraction? Positive 1/2. So let's say that we had no idea how to get that to reduce without using our calculator. Do we know how to type it in? So your calculator will do it for you if you type it in. So to do that, you just type a fraction, negative 3 divided by negative 6. Math, enter, enter. We'll change it to the fraction of 1/2. It will simplify it for you. So if you don't know that off the top of your head, it's not a big deal. You don't have to. So our goal now is to look for opposite reciprocals. Do we see any fractions that have flipped fractions and opposite signs? Which sides? Okay, so the name of those segments are what? Okay, so the way we write our segment is AP is perpendicular to XP. Or you could flip it, you could put XP first, but the goal here is to find the 90-degree angle. So we're looking for perpendicular slopes. The symbol for perpendicular looks like an upside down capital T, and it also looks like 2 perpendicular lines. So AP is perpendicular to XP. Therefore, triangle AXP is what kind of triangle? We didn't find side lengths, we found slopes. What kind of angle is sitting inside that triangle? Okay, a right triangle. So that means these are perpendicular. This is a 90-degree angle because this slope and this slope are perpendicular. So our answer is triangle AXP is a right triangle. Now, we could definitely calculate the side lengths. We could determine that it's a scalene right triangle. But for this problem, it just wants to know if we have perpendicular slopes, yes or no. Okay? So what we're going to do on the next page, on page 14, you're going to do the next two examples. Those are asking for right triangle problems. So what you're going to have to do is calculate the slopes of all the sides and compare. If none of them are opposite reciprocals, then it is not a right triangle, and that's okay.